Hi, I'm Gareth Spence and welcome to Tech Talk. At this year's OFC, Adtran is making the headlines with the launch of LiteWave800, a linear pluggable optics module that's setting a new benchmark for intra-data center connectivity. To provide details on what makes this module so special, I'm joined by Adtran's Ross Saunders. Ross, what is LiteWave800?
So LiteWave800, it's an LPO, a linear pluggable optical module that has very low power. So it eliminates the retimer module that's inside the module, and it also uses very low power consumption VCSEL, single mode VCSEL technology that can bring the power down in the module. And then we also use our in-house drivers and transimpedance amplifiers that really create a very low power module, 1 picojoule per bit. So it's an 800 gig module for 0.8 watts.
That 1 picojoule per bit, is that a new standard, a new benchmark for the industry?
Yes, so it drives the next level of energy efficiency. So typically, LPO modules half the power consumption of typical modules. But with our module, we go from 5 or 6 picojoule per bit down to 1 picojoule per bit. So it's quite a dramatic improvement in the efficiency.
And is that power efficiency the key thing that this module addresses that data center operators will find so appealing?
Yes, a big challenge is actually feeding enough power and cooling into the data center. So if we can drop the power consumption on the optical transceivers, that can save a lot of money, but also allow higher scaling in the data center.
What makes LiteWave800 different from first generation LPOs?
So first generation LPOs, they would typically use silicon photonic Mach-Zehnder modulators or EML, external modulated lasers. This one is really novel, it's unique because we're using single mode VCSEL, vertical cavity surface emitting lasers that require very low drive current. So that allows us to really bring the power consumption down.
How does Adtran's vertical integration give LiteWave800 an edge?
So we have a lot of experience in single mode VCSELs from our Micromux and our Micromux Nano products. So we already have quite a lot of experience of using single mode VCSELs and how to couple it into a module. This one is also using our own in-house driver and TIA, where we develop our own chips, optimized using a very low power consumption process. And that's really the key secret inside the module is the VCSELs combined with using our low power drivers and TIAs.
How does the new module integrate with existing data center equipment?
So, I mean, you can plug it in. There's a standard on the LPO MSA. So we're members of the LPO MSA, and we can interoperate with other LPO modules.
What type of workloads will benefit most from this?
So, I mean, you can use this because the reach can be up to 2 kilometers. So this can be used for really scale-out applications if you're trying to interconnect, say, from GPUs into switches in the network. That's really the key application there. In the future, we may be able to adapt this technology to also work for scale-up applications. That may be a different package, not in an LPO, but the same guts of the product we can use and put it into a near-packaged optics or a co-packaged optics.
And what does LiteWave800 mean for the future of AI infrastructure?
Well, it's driving a new level of energy efficiency or low power consumption. So I think we set a new bar where we can really help to scale up the AI optical interconnection. Not just between GPU scale-ups, but even there's applications for memory pooling where you have to communicate with a dynamic shared memory pool. This is kind of the way things are going in the future. So it can work for all those applications. We can use this technology, not just in an LPO module, as I said, there's other applications where we can help to enable that scaling of AI data centers.
Ross, thanks for joining me today.